Hello everyone. I thought of starting a video series for the paper discussions, focusing on the students who are going to do A's and A level, Cambridge A's and A level this year, October, November. So first, I thought of start with the mathematics part for the A level and specifically the mechanics paper. So as the first one, I selected the math, the paper October, November 2024, paper 41. And okay, so there are some instructions that, mm, as you know already, you have to read them carefully. So in there, I should say that here, the correct answers you should keep in three significant figures, your answers, or one decimal place for the angles, and then for the gravity. You have to take it as 10 meters per square second. Okay, so now let's start with questions. Okay, so the first one. Okay, two particles of mass is 1.8 kilogram and 1.2 kilogram are connected by a light inextensible string that passes over a fixed smooth pulley. Particle hand vertically. The system is released from the rest. So here, okay, so they say that it's released at rest, and then they ask you to find the magnitude of the acceleration of the particles and find tension in the string. Okay, so in general, what I'm doing is I'm making a sketch for these scenarios. So then we have like it is easy for us to have a clear idea about like what happening there. Okay, so we have a police. So it's okay. It's no need to be perfect. Just make some sketch. So we have a one mass here, and there is another one this side. Okay, and let's take. Okay, so we don't know which mass is higher or lower, and also whether they are in the same level, because here they don't explain anything. So I just take okay, let's take this one as 1.8 mass, and so the weight, in order to find the weight, you have to multiply by g. So again for the other one, it is in 1.2 g, the weight. And for easy, let's name these masses A and B. Okay, so then when we write equations, it's easy for us to like call them. Okay, and then tension. So it's a continuous string. So the tension all around the string is the same. So it's a tension. So in general, we indicate like this. Okay, the tension, and then we have to consider the acceleration, because now they are at rest, but here the masses are not in balance, like their masses are not balanced, right? So we can assume that the mass with the higher weight will start moving down. So still they didn't, but let's assume that it starts to move downwards. So A, so then the mass A starts to move downwards, and mass B starts to move upwards with the same acceleration, because they are connected. Okay, so then for the first question, what they're asking, find the magnitude of the acceleration and the particle, and find the tension. Okay, so first we have to find out. Okay, so now here, as you can see, there are two unknown variables. So probably we have to not probably actually, we have to solve a simultaneous equation because we have two unknown variables, so we have to make two equations to find them. Okay, so what I'm going to do is I'm going to consider the particle A. So I can write for particle A downwards because it starts move. We assumed that it starts to move downwards, so we can write we can apply F equal ma downwards. So we consider particle A. So in that case, downwards we have 1.8 g, and upwards we have minus t. Upwards we have t, and then the mass is 1.8 times A. So let's take this is the equation 1. And then for particle B again, we can apply F equal ma upwards because particle B is start to move upwards. So then upward forces acting on particle B. We have the tension upwards, and downwards we have 1.2 g the weight, and then 1.2 times A. So we can consider this is the equation 2. Okay, and then these are simultaneous equations. So as you can see here, you have in the first equation you have minus t, and for the second one you have positive t plus t. So if you add those two equations, you can cancel them out. So by taking equation 1 plus 2, so we can write, so dt cancel. So you have 1.8 g minus 1.2 g, and equals here the other side you have 1.a plus 1.2a. Okay, so from here you can have so 1.8 plus 1.2 is 3, so we can write here 3a equals to here you have 1.8 minus 1.2 is 0.6, and g is 10. Therefore a equals 0.6 times 10 divided by 3. So it's 6 divided by 3 is 2 meters per second square. Okay, so we found it, and then you can use any of those two equations and find E. So I will take equation from equation 2, let's say. I can write E equals 1.2a plus 1.2g. So I took everything to one side, and so 1.2 times acceleration is 2, then 1.2 times here 10. Okay, so the tension we will have 1.2 times 10 is 12, and then here 1.2 times 2 is 2.4. So the total is 14.4 newtons. Okay, done. So we have to keep in 3 significant figures, and yes, 14.4 is in 3 significant figures. Okay, right. Now let's move to the second question. So here, okay, we have this inclined surface, a particle of mass 7.5 starting from rest at A slides down an inclined plane AB. The point B is 12.5 meters vertically below the level of A as shown in diagram. Okay, so given that plane is smooth, use an energy method to find the speed of the particle at point B. Okay, so I will indicate the initial cases. So there are okay, so the key thing is here starting from rest, right? So then the initial velocity is 0, and then when it is moving or when it reach to point B, let's assume the velocity is v. Okay, so given that the plane is smooth, so we don't need to consider about the friction. Okay, use an energy method to find the speed of the particle. Okay, so how we can do here? So since we don't have any resistance, so then there's no energy loss due to the resistance. So only the thing is then the when it reached to point B, it gained the kinetic energy because it has a velocity now. And we can consider at this bottom level the potential energy as 0 at this bottom level. Okay, so then we can take the gain in kinetic energy equals to the change in gravitational potential energy, right? So okay, it's better to write it down. Gain in kinetic energy equals to the change in gravitational potential energy. Okay, so kinetic energy we can write half mu square, so we don't know the velocity. And then the gravitational potential energy, we know that mgh. And so here you can cancel out the mass, and then we need to find the velocity. So v square is by cross multiplying to gh here. Okay, and therefore we can write v equals square root 2gh, and so 2 times g is 10 and height is 12.5 meters. So by using the calculator you can find the answer here. It's 15.8 meters per second. Okay, so this is the velocity. So I would say that when you do these kind of exercises, just indicate this information. So then for the person who is checking your paper can understand easily, okay, what you have done here and how did you consider everything. And so he knows what are the variables that you have used here. And so it's easy for them to check your paper, and sometimes it may be a plus point for you. Okay, right, now let's consider the second part. Okay, it is given instead that the plane is rough and the particle reach B with a speed of 8. The plane is 25 meter long and the constant friction force has magnitude of, okay, this one. So now it is the same case, but now they gave us the velocity. So I will just draw here the situation. So we have this point A and initial velocity is 0, and then here we have the second place, point B, and here they gave us the velocity 8 meters per second, and then also the length, right, or the distance from A to B. So A to B distance they gave us as 25 meters. Okay, and then there is a constant friction force that has a magnitude of, okay, so let's say here somewhere in the middle, so it's moving downwards, so we have this upwards friction force F. Okay, so then what happened now? When it is moving from A to B, then the potential energy decreases, and then when the potential energy decreases, the kinetic energy increases. Also, this particle uh, should do some work against the friction also. Okay, so then in this case you have to consider all of these. So then the total potential energy, okay, the total potential energy is equals to the kinetic energy it gained and also the work done against the friction. So we can find one by one. So first let's find the kinetic energy at point B. So kinetic energy at B. So I will use kinetic energy at point B. We can use half mv square, and here half m is 7.5 kilogram times the velocity is 8, so 8 square. So by using the calculator you can find the answer here. So it is 240 joule. Okay, and then we can find the decrease in potential energy. Okay, so or let's say the decrease in potential energy, or for the potential energy of the particle at point A. So potential energy at A. So I write potential energy at point A. So these are some short forms. So mgh equals 7.5 times 10 times the height was 12.5, right? Okay, so it was 12.5, so you can multiply it, so it will be 937.5. So in this case you no need to keep the answer in 3 significant figures, because this is not our final answer. And also we have to do some work against the friction. So we can write the work done against the friction. So let's take that one as a work done. So normally we use W. So work done against the friction. Okay, let's see. So the work done, you can write Fs, force multiplied the displacement. So here F is F, and the distance between A and B is 25. Okay, so let's keep that. Now what you have to do is we can consider the energy conservation. So we can write considering the energy. So sorry. Energy conservation. But we can write. So potential energy at point A should equals to the kinetic energy at point B plus the work done against the friction. Okay, so we have all these values. So the potential energy is 937, 7.5, kinetic energy is 240, plus the work done against friction is 25 times F. Okay, so then it's simple. So 937.5 minus 240, and then divide by 25. So therefore F equals 27.9 newtons. And don't forget to write down the units. Okay, So now question 3. So let's see what we can do here. Okay. A curve planar force and planar forces of magnitude 52, 39, and act at a point in the direction shown in the diagram. And here the important thing is the system is in system is in equilibrium, right? Okay, so it's in equilibrium. Then what you should know, in general, the main thing you should remember, okay, this is a 2D, right? So we have only x direction and y direction. So if a system is in equilibrium, then the total force in x direction, the sum of the total force in x direction is 0. Then total force in sum of the total forces, sum of all the forces in y direction is 0. And then there is another one actually. The total momentum around any point of the system is 0. So this is the condition for a system to be in equilibrium. Okay, and if it is 3D, then we have to consider all the forces in z direction, and you don't have that one. Okay, so when they say that the system is in equilibrium, you have to remember this concept. Okay, so now find the values of p and theta. Okay, so now we consider the x direction and y direction. So 52 and 39 newtons, they are okay. They are in x directions and y direction. But the force p, so we have to take the component. So I can rotate this force p to make it horizontal. So we can write p, and here in the rotation direction you have the anchor. So easy way to remember is that p cos theta. Like if you have the angle, then take it as a cos theta, and then the other one, the vertical one. So you can rotate the force vertically, and then you have downward p sine theta. Okay, so now instead of this force p, we can use its component. Okay, so now what you have to do is, since they are in equilibrium, you can consider the sum of the forces in x direction. So I will write sum of the forces in x direction and indicate direction you are considering as positive. So I am considering the forces in the right direction is positive. Okay, so I can write to the right direction we have 39, and to the left side we have p cos theta is equal to 0. And so from this one, okay, remember for this kind of questions, just subject p cos theta or something like that, because we don't know p and cos theta. Okay, and this is 39. Let's say this is equation 1. And for the vertical, and let's consider upward forces are positive. So the summation of y direct for sum of the forces in y directions are 0. So upwards we have 52 minus downwards we have p sine theta equals to 0. And again, I'm going to subject p sine theta equals to 52. Okay, equation 2. Right, now here you have two equations, and as you can see, if I divide these two equations, we can cancel out p, and then we can create tan theta. So what I'm going to do is here, from equation 2 divide by 1. So 2 divide by 1. So we have p sine theta divided by p cos theta here. And so here we have 52 over 39. So then PP cancel. So we have tan theta equals to 52 over 39. And from that one, theta equals to tan inverse 52 over 39. So you can use the calculator, and from that one you can find theta. Therefore theta equals 53.1 degrees, and we have to keep for one decimal place. Okay, so now you know theta, and so you can use either equation 1 or 2 and calculate the value for p. So I will take just equation 1. From equation 1, p equals here cos theta I should bring to the other side. So here divide by cos theta, and yeah, I would tell you that in case if you don't have enough time to solve or use the calculator, then just take 39 divided by cos theta is 53.1. Okay, but I would recommend use the theta value exact theta value. That means, because this is our final answer. Okay, if you receive a value for theta like 60, 70, or let's say directly 53.1 or something, then yes, you can use it. But otherwise, okay, don't use that value directly, because we round up the value. So here for theta, if you calculate it, you will receive 53.11301 and so on. So here we rounded up here and kept here 53.1. So don't use that one. So I would write like this. Instead of theta, we can write tan inverse 52 over 30. So you can type this one in a calculator and find. So it is then 65 newtons. Okay. But sometimes you will receive the same. So it's fine. Like in case if you don't have enough time, then just substitute the value you have here. Because if I will just write here, so I can do the same with 39, and here I can write cos 53.1. Then you will receive 64.95 and so on. So still yes, we can round up this one. So keep that in mind. Okay, so the answer is 65 here. Okay, so now let's move to the fourth question. Okay, they say that a bus travels between two stops, A and B. Bus starts from rest at A and accelerates at a constant rate of A until it reaches a speed of 16. It then travels at this constant speed before decelerating at a constant rate of this one, okay, 0.75 n. Coming to the rest at B. Okay, the total time for the journey is this one. Sketch the velocity time graph. Okay, so the first part is he's moving with the bus is traveling with an acceleration of A. So it's a constant acceleration. So you should know how to draw the acceleration. So if it is a constant acceleration, then it's a straight line passing through the origin, right? And then after that, But they're saying, okay, it reached to the velocity of 16. And then it continues with that 16 for a while. Okay, let's say we don't know actually. This one moves with a constant velocity and then decelerating at a constant rate of 0.7. So if you want to be precise, you have to consider the slope of the acceleration part, because in the first part the acceleration is just a, and in the second part or deceleration part it's a little bit higher, zero, because it's 0.75 times a, right? Therefore what you have to do is okay, so sorry, I made a mistake. So it's 0.75 means 75%. So then it's a little bit smaller than the previous. So we have to make uh, the angle a little bit, or the with the less slope. Okay, so slope is not bigger. Okay, so now this velocity is 16, and we have to consider this time durations. So let's say this is O. Okay, so the final time is 214 because for the whole motion it takes 240. So okay, this is the sketch, and then they say that okay, find an expression in terms of a for the length of a time that bus travel with a constant speed. Okay, so let's say for the acceleration time period, let's say t1, and for the deceleration, let's take t2, and the time duration, it travels with a constant velocity, let's take t, capital T. Okay, so we have to find an expression for t in terms of a. Okay, how we can do that? So we know the total time now, right? So if you want to find t, you can find in a one way that if you can find t1 and t2, and then you can subtract summation of t1 plus t2 from 240, and then you will have t, capital T. So first let's find t1 and t2. So by considering the acceleration, so we can write acceleration a equals, so from a velocity time graph, from the gradient we can find the acceleration. So we can write 16 over t1. So from this one, t1 equals to 16 over 8. Then we can consider deceleration. So deceleration. So in that case, 7.5. Sorry, 0.75. 0.75a equals 16 over t2. So from this one you can t2 equals 16 over 16 over 0.75a. So I would simplify a little bit. So 16 divided 0.75. You will receive 64 over 3a. Okay. Now we know t1 and t2 in terms of a. Then we can write the time spent for constant speed. It's capital T. So we can write the total time taken for this one is 240 minus t1 plus t2. Okay, so therefore we can write t equals 240 minus, here you can write 16, A plus 64 over 3A. So if you want, you can simplify this further, and so T equal 240. So here you have 16 plus 64 over 3. So you will have here 112 over 112 over 8. Oops, 112 over 3A. Okay, you can keep this answer or this one. It's fine. Okay, then the next part. Given that the distance from A to B is 3000 meter, find the value of A. So, how we can do? So, in a velocity time graph, the distance we can find by calculating the area under the graph. So, I can write distance traveled equal to area under graph. So the distance traveled is 3000. So area under graph. So this is a trapezium. So what you can do? We have to add, okay, probably you know how to find the area of a trapezium. So you have to take the summation of the parallel lines. So here one is T and the other one is 240, the bigger one. And then also we need the height. Height is 16. So I can write T plus 240 divided by 2 times 16. Okay. So now here I can cross multiply. So I can simplify here. I can simplify. So I can bring 2 to the other side. So 3000 multiply 2 and divide by 16. Then you will receive 375 equals T plus 240. And for I can bring 240 also to the other side. So 375 minus 240, 135. And for T we have this value. So we found previously 12 over 3A. Okay, so from this one, what we can do? So I can bring 112 over 3A to the left side and 135 to the other side. So then I can write here 112 over 3A equals to 240 minus 135 is 105. And then I can find A by cross multiplying. So then 112 equals to 105 times 3A, and so I can divide by, so I can subtract A. So if you subtract A, then answer is 112 divided by 3 times 105. So you will receive here 16 over 45 or equals to, you can keep this one, or for 3 significant figures it's 0.356 meters per square second. Okay, so here I do the simplification quickly. So it is important for you to practice more the simplification, so which makes or which increase your simplification. Okay, simplification speed. Okay, so now question 5. Okay, so they are saying that particle A is projected vertically upward from a point O with a speed of 80. 1 second later, a second particle B with the same mass as A is projected vertically upward from O with a speed of 100. So at time t, after first particle is projected, two particles collide and coils form a particle. See, okay, so that means after collision they stick together and create another particle. Okay, so it's, remember, they are projecting at the same point. So let's say particle A is projecting with the speed of 80. And after 1 second, particle B is projecting at the same point. Okay, so here I just to show you 1 second. So I draw this one separately, but remember the particle A and B are projecting at the same point. Okay, and then what happened after some time? So that means they are moving in the same line. So then at the one point, this is A, this is B, right? So at one point they stick together, and to travel for this up to collision, the time taken is t. Okay, so after t time they stick together. Okay, so now show that t equals 3.5. Okay, so let's try. So we need to find the time. We don't know the distance, right? For the collision. So this distance we don't have any idea. Okay, so let's consider it as A or something. Okay, so I will write for particle A, gonna apply upwards, S equal ut plus half at square, because I know the initial speed, and also we know the acceleration, and we know the time, it is t, and the distance we don't know. So for the moment, let's say SA, and the speed is 80, and this is moving upwards, so it is minus g. Okay, and then for particle B, gonna apply the same equation. So S equal ut plus half at square. So let's say SB, the initial speed is 100 times t. I should keep minus g because it's moving upwards and the gravitational acceleration is downwards. Oops, sorry. Yeah, t square. Sorry, I made a mistake here. Because, okay, when we consider for particle B, it projected after 1 second, right? Compared to A. Therefore, I should write 100 times t minus 1. Okay, because after 1 second we are projecting particle B. So minus half g, and here t minus 1 square. Okay, I will take, this is equation 1, this is equation 2. And then what we can say at the collision point. So if this is a particle at the collision point, the distance the both particle A and B travel are the same, right? They are at the same height at the collision. So I can write at the collision, both particles are at the same height. Okay, therefore we can write SA should equal to SB, right? So then I have this equation. So for SA, 80 minus half GT square equals to SB is 100 T minus 1 minus half G 1 square. Okay, so now we have to simplify. But so here we have half, so I don't like it. So you can multiply all the terms by 2. So I can write here then 160 T minus G T square equals here when I multiply by 2 it's 200, and then I'm going to expand the bracket. So it's 200 T minus 200, and then here 2 to cancel, and then I can write G times the expansion minus 2T plus 1. Okay, and then here as you can see we can cancel minus GT square, and here also when you multiply multiply the bracket with G, we will have minus GT square, so we can cancel it. Okay, so what else? Okay, that's it. And so we have here 200T. So I'm going to take everything to the right side, and so we have 200T and minus 160T, and then plus we have here G minus G times 2T, so minus becomes plus, so 2GT and equals the other side. We should bring all the constant values. So we have minus 200 goes to other side, so then it's plus 200, and then we have minus G and it goes to other side plus G. Okay, so here we have 40T plus here G is 10, so it's then 20T equals to here G is 10, so 210. Okay, so then T equals to 210 divided by 60, which is 7.2 or 3.5 seconds. Done. Okay, so we showed that T is this one. Okay, then what they're asking, find the height above or at which particles collide. So now you know the time, so you can use either of equation and substitute the time value and find the answer. So from, let's say, equation 1 here, S equals from equation 1 80T, so we can write 80 times 3.5 minus half G is 10 times here 3.5 square. So S equals, you will have here 875 over 4, which is 218.75. Or for 3 significant figures, we can write so 218, so 219 meters. This is for 3 significant figures. Okay, so 290. Right, then the next part, they are saying okay, find the time from A being project until C returns to A. So what they are saying that we projected these, and then from A and B, it formed the particle C, and so we don't know the velocity at that point. So probably it's moving upwards and then moving back, and yeah, it will reach to again. Oh, so they're asking the time. Uh, okay. So the main thing is we don't know what is the velocity after collision. And for that one, we need to know what are the velocities before collision of particle A and B. So we can take okay, we can write let's take the velocities of particles, sorry, particles A and B as VA and VB. Okay, so I will write for particle A upwards V equal U plus AT. So let's say VA equals to AT minus 10 times, and the collision happens at 3.5. We found that. So then it will be 45 meters per second. And also for particle B, the same, V equal U plus AT. And remember, when you apply these motion equations, try to indicate the direction you are applying this equation. So it is easy for the person who's checking your paper in which direction you apply those equation and all. Because these are vectors, right? And this is 100 and 10 times. So we projected it 1 minute after, right? So then this one. Okay, so then 75 meters per second. Okay, so now what happened? There is a collision, right? So we can say before collision. Before collision, what happened? Here we have particle A, let's say the mass is m. It's moving with 45. And behind that particle B, let's say they are the same, reaching with 75. And then after collision. After collision, what happened? They are stick together and form C. So now mass is then 2m. And let's say VC. We don't know that, and we are going to find it. Okay, so we can say considering during the conservation of momentum, oops, don't mind about my handwritings. Momentum. Okay, so we consider upwards. So we can write by considering particle A, which is m times VA, plus particle B, m times VB, and 2m times VC. So here we can cancel out masses. Okay, so VA, VB we know, which is 45 plus here 75 equals to 2 VC. So from this one you can find VC. 575, 120 divided by 2 is 60. Okay, so we know that now Um, we know that now. What is the height it reached? Okay. Hmm. So now what we have to do? So now if I make a sketch for this case, here we have the ground here, and then okay, this is the point of the collision. So this is the velocity vc, and then what will happen? It will move to a maximum height and then reach down, and then the the distance for the collision occurs is, we found that it is 219, and remember it is for the three significant figures. So our correct answer is this one, 280.75. So here 218.75 meters. Okay. So then what happened? What you have to do here? We have to find out time. So you know the distance, because since okay, the motion start from this point and it moves upwards, okay, we don't care, and then it reach to the same point. So anyhow, the object should move this amount of the height, which is to 218.75 downwards, right? Okay, remember that one. So what I'm going to do is here, considering the collision point to O, considering the collision point to O, O motion. So I'm going to apply upwards is equal ut plus at square, because they are asking the time. So the now when you reach to O, our total displacement is minus, because we can consider that this the collision level is our displacement 0, right? So then when it reach to point O, then it should travel negative 218, because it's moving below our 0 level. So we can assume like that. So I should write here minus 218.75 equals to, now we found the velocity, which is 60, and okay, let's keep time t, and we applied upwards, so half g is 10, and here t square. Okay, and then we can multiply. Okay, 2 and 10 we can cancel, so we can have here 5, rearranging this, 5t square and minus 60t plus, right? Yeah. Then okay, plus, oh no, sorry, I'm taking everything to the left side, so then it's minus 218.75 equals to 0, and then from, okay, you can use the calculator or the formula. So you will receive T equal 12 plus root 319 over 2, or T2, because since it is a quadratic equation, you should receive 2 answers, right? And but we know that T is, the time cannot be negative. So T2, if you simplify T2, then you will receive a negative answer. Therefore, time is 12 plus 319 over 2, which is 14.93 seconds. Then we can write therefore the total time. So the total time is, we can say, t plus cap. That means move from O to collision point, capital T, and then coming back. So it was 3.5 plus 14.93. So we will receive 18.43. And so for 3 significant figures, it's 4 seconds. 18.4 seconds. Okay, done. Now let's move to the next one. So here what they're saying, a particle of mass 1.2 kilogram is placed in a rough plane. Okay, so now it's a rough plane. Then there is a friction force. Incline there. Okay, angle is theta to the horizontal, and sine theta is this one. The particle kept in equilibrium by horizontal force, magnitude of P, acting on in a vertical plane containing the line of the greatest slope C. Okay, the coefficient of friction between the particle and the plane is 0.4. So that means mu is 0.15. And also let's take this one. So this is theta. So they gave us sine theta. Sine theta is 7/25. So that means opposite over hypotenuse, right? So this is 7. Opposite is 7. And the hypotenuse is 25. So by using Pythagoras, you can find the adjacent, which is 24. So with this one, you can write what is cos value also. Now let's indicate what are the forces acting on this. So we have the weight here. So here I have 1.2 g, the weight, and then we have contact force, which is perpendicular to, okay, I think it's perpendicular. Okay, it is perpendicular to the surface, right? The contact force, let's say R, and then this angle is theta, right? Because this angle is 90 minus theta, and so since these two angles are 90, then this angle should be theta, right? So you should remember. And also here, this angle should be theta because it's, if you remember in math, these are, so two lines are parallel and this is the Z shape angle. Easy way to remember. Okay, they should be equal. And then let's assume like if you remove this horizontal force P, what happened? This particle should move downwards. Then we can indicate, okay, there is a friction upwards. We assume that one. Okay. Right. Now what we have to do? So now it is in equilibrium. Okay. So find the least possible value for P. Okay. So in that case, here I can write 1.2 g cos theta, and also there is another component 1.2 g sine theta of the weight, and then from this force P, we have upward along the surface, there's a component P cos theta, And then we have perpendicular to the surface. We have force P sine theta, because by rotating this way and this way. Okay, right. So now we have to find out the value for P. So these are the forces. So I can apply perpendicular to the surface, F equal ma. So then what are the forces perpendicular to surface and upwards? So we have R minus, I have 1.2 g cos theta, and also we have P sine theta, minus P sine theta equals to 0 because it's in equilibrium. So acceleration is 0. From this one, I will write R. R equals, so I should bring all this to the other side. So then 1.2 times G is 10 times cos theta. Cos theta is 24 over 25. So when you simplify that, you will see 288 over 25 plus, and sine theta is 7 over 25. So 7p over 25. Let's take equation 1. Then I'm applying F equal ma parallel to this inclined surface upwards. So upwards we have force friction plus the component from force P cos theta, and then we have minus 1.2 g sine theta equals to 0. So from this one I am going to subject F. F equals again here 1.2 g is 10 times sine theta 7 over 25. So when you simplify, you will receive 84 over 25, and P cos theta. Cos theta is 24 over 25. When it goes to other side, it's negative. So 24p over 25. Okay, so we have these two. And then what we can do? We can consider F, the friction. We can write mu, the friction coefficient, times the contact force, right? So then we have two equation for F and R, so we can substitute. So F is 84 over 25 minus 24p over 25, and mu, which is 1.4 we had previously, and R is 288 over here 25 plus 7p over 25. So as you can see, it's, the 25 is common, right? So you can cancel out, okay, because each and every terms we have this 25 in denominator. Okay, so then what we can do? Yeah, we can simplify. So we have this 20. Let's say here we have 84, and then minus 24p, and the other side we have 288 times 0.15, which is 43.2, and plus 7 times 0.15, which is 1.05p. And so with this one we can take 24p to the other side, so then it's plus, so it's then 25.05p equals to 84 minus 43.2, which is 40.8, and so P equal 40.8 divided by 25.05. So you will receive 272 or 167, or in decimal. For the three significant figures, you can write it is 1.6287 and so on. So I can write 1.62 newtons. Okay, it's done. Okay, for that one we have only that. Okay, then the next question. I think here we had to find only that one. Find the least possible value for K. Okay, so that's it. And question 7. A car has a mass 1,200 kilogram. When car is traveling at a speed of v meters per second, there is a resistive force of magnitude kV Newton. The maximum power of the car is this one. Okay, so we have to find K first. So in that case here, let's say this is our car, and when it is moving with v meters per second, then there is a resistive force of kV newtons, and the P maximum power is this one, 92.16 kilowatt. Okay, so K equals so we can write the power P equal FV, right? And where in this case the force we can write, because here they say that okay, as a great possible speed of 48, and here they say that traveling speed and resistive force is this one. Okay, so where we can write in this case F equal kV they gave us, so we can write here power equals to, instead of force we can write kV times V. So then if I subject K, so then it is P over V square. So the power is 92.16 kilowatt, therefore 10 to the power 3. And velocity here they gave us as 48. So 48 is square. So from this one, when you simplify, you will receive 40. Okay, that was easy. Right, then they are asking at an instant when speed is 45, find the greatest possible acceleration. Okay, now what happened? Again, we can use the same power equal FV, and then here what happened? We have to find out the driving force, because of the power of the engine we have this driving force, right? And here at an instant the speed was 45, previously 48, right? So then that means there's something happened, there's a change in force. So let's try to find like this, the driving force. Instead of force, let's use driving force. Therefore I can write the driving force, or dF, equals to power over velocity. So power is still 92.16 and 10 to the power 3. and now the speed is 45. Then you will receive 48 Newton. Okay, then we have to find the resistive force, or we can say the resultant force, because now if I take the car here, so we have the driving force and we have the resistive. So we have the resistive force, right? Here we have the resistive force. Then we can say that if it is accelerating, then that means there is a resultant force, right? According to F equal ma. So if we have an acceleration, that means we have a force. So we can write, therefore, the resultant force was equals to ma, resultant force on the car, let's say, and then that is the driving force minus resistive force. Force here equals to ma. Okay, so now acceleration equals to what? The driving force minus the resistive force divided by m. Okay, so now let's find. So the driving force, we found that it is 2048 minus resistive force is given by kV, right? They gave us in the beginning. So k value is 40 and the velocity at that point is, at that instant, is 45. So 40 times 45. Okay, so I here this resistive force is given by kV. Okay, and divide by the mass is 1200. Okay, so when you simplify it, 150 and equals to 0.207 meters per square second for 3 significant figures. Okay. The car now travels at a constant speed up a hill, inclined at an angle of sine 0.15 to the horizontal. Find the greatest possible speed of the car. Okay, so now it's let's try to sketch this one. So we have this. So now the car is moving here up a hill. So we have the weight of the car, and we have the contact force perpendicular to the surface. Okay, and then let's say this angle is theta, as they're saying that theta equals sine inverse 0.15. So that means sine theta equals to 0.15, or we can say it's 3/20. Okay, so here we have 1200 G, and we have here R, and then what else do we have? Here we have the driving force, and we have the resistive force, which is given by kV, and the velocity at this point is v. Okay, right. So what we can do is we do okay yeah. Okay, so now they are saying that okay, it's with a constant speed, so then there's no acceleration, right? So I can apply here F equal ma. So the driving force minus the resistive force minus I have a component from the weight, right? So 1200 G, and this angle is theta. So we have a component for this side, which is sine theta equals to 0. So from here I can write dF equals to velocity is 40, right? No, k is 40. We don't know the velocity. So 40 v plus here 1200 times g is 10 times sine theta is 0.15. So then it is 1800. Okay. And then let's keep let's keep this equation as equation 1, and then also we can write this driving force is power over velocity. We will keep this one. So then by equating these two I can write, therefore the power is 92.16 10 to the power 3, and the velocity we don't know, v, and on the other side we can write 40 plus 1800. So by cross multiplying we can cross multiply here, so then we will have 14 v square plus 1800 v, and then minus here if I multiply by 10 to the power 3, 92. So it is 92,160 equals to 0. We can, if you want, you can divide all by 40, or you can now directly use the calculator to solve this quadratic equation. So you can use the formula. So you will receive two values. One is 30.5, let's say V1, or V2 is minus 75.5. So here, if we consider a negative value, then that means our direction is wrong, because we applied we considered the movement direction is upwards. So if we consider negative, it's downwards, right? Therefore we have to consider v as the positive one. So since the car travels up the hill, here, so the velocity is 30.5 meters per second. Okay, so okay, it is done, and now we are reaching to the final question. Okay, so question 8. So this is our last question. Here, the particle P moves in a straight line, passing through a point O with a velocity of 4.2 at time t. After passing, after passing this O, accelerate with an acceleration of a, and P is given by this equation. So if I make a small sketch for this case, here let's consider this is point O. So this particle moves at this point with 4.2 meters per second, and then after t time, there is a point, the acceleration is a meters per square second, and then okay, it comes to this instantaneous rest. Okay, so find the distance v travels between time at which the instantaneous rest. But here in this case, first instantaneous rest means it doesn't move, and so the velocity is 0. So you have to first find the velocity. But they gave us the acceleration equation, so you can find it by taking the integration of the acceleration in terms of time, right? So it is 0.60 minus 2.7 dt. Okay, therefore the velocity you can write here 0.6 t square over 2 minus 2.7 t plus c1, because here this is not a definite integral, right? So c1. Then I can write, therefore v equals here 0.3 t square minus 2.7 t plus c. And we can find c by considering at point O, because at that point you know exactly what is the velocity and the time. So at point O, we consider its time 0. So we can say at point O. At point O, v equal 4.2 and time equals 0. Therefore, we can find here 4.2 equals 0.3, time is 0. Here 2.7, time is 0 plus c1. Okay, therefore c1 equals to 4.2. With that one, we can write the final equation for the velocity. It's 0.3 t square minus 2.7 t plus 4.2. Okay, let's keep it in mind. And then at the instantaneous rest, again the velocity is 0. So I can take at the instantaneous rest. Instantaneous rest, v equals 0, which is 0.3 t square minus 2.7 t plus 4.2. Okay, it is equals to 0. Right like this. This is 0, and so you can divide all by 0.3. So then 3 square minus 9t plus 14, 0. So we can, you don't need to use the calculator for this one. So the multiplication is 14 and the difference is, summation is 9. So here I can take minus 2 minus 7. So from this one I can say t equal 2 or t equals 7. Okay, now let's keep that in mind. So that means here in our sketch, it comes at t equal 2 and also travel another and rest at t equals 7. Okay. And then since we need to find the distance, you have to again integrate it the velocity. So s equals, so velocity equation you know, here t square minus 0.7 t plus 4.2. equals, sorry, dt. And okay, I can write the answer here. 0.3 cube over 3 minus 2.7 t square over plus 4.2 t plus c2. But again, we have a constant c2, we don't know. But we know that at point O, the distance, displacement is 0 and time is 0. So with that one, you can find c2. So s equals 0, and all the other three terms is 0. So 0 minus 0 plus 0 plus c2. So from this one, c2 equals 0. Then I can write the distance. S equals here 0.1 t cube here minus 1.35, 2.7 divided 2 plus 4.2 t. Okay, then I can find the total distance traveled. Total traveled. So t equal 2 and 7. So in between these two times, we like it moved, right? So we have to take the difference of these two. So s equals, so first we will take, okay, how long it would travel within 2 seconds. So it is 0.1 here 2 cube minus 1.35 2 square plus 4.2 times 2. Then minus within 7 seconds. So 0.1 and 7 cube minus 1.35 7 square plus 4.2 times 7. So here you will receive 1905 minus, for the second bracket we will have minus 49 over 20. So you have to, since we have negative times negative, you have to add these two. So it is 25 over 4, which is 6.25 meters. Okay, so with this one, we concluded the paper. So thank you, and see you with the next paper. Bye.